Hello, so today I'll be talking about how to install and set up the Runtime tester for testing time efficiency for your Java code. So the first step is to open the link to the GitHub page where you download it. That I've got saved right here, but of course it's also available on my courses and in this video's description. You click on the Releases tab here and you click on the latest one. And then you simply click Download on whichever .jar file corresponds to your operating system. Here we're running Windows, so we're going to take Runtime tester -windows.java or .jar. I'm just going to download it here. Then I'm going to open my IDE. All you need to do is have a Java project open. To add our library to Intellij, we click this folder with the 3 squares icon, Project Structure, or Control-Alt-Shift-S. We click on Libraries plus New Library. Then here we've got our folders. We simply drag our library in from the File Explorer and press OK. To add a library in Eclipse, we right-click on our project, click Properties, Java Build Path, Class Path, Add External Jars, and we select our jar file. And now I have it here. Now nothing appears to have changed, but if I create a file now, I'm going to create a Java class. I'm just going to call it my class. And I run it, so I go public static void main string words, and I type visualizer dot launch my class dot class. Then it's going to open this window, which has a graph of the time complexities of my various methods. Now this grapher is actually where we're going to see the speed of our code. By default, we've got some built-in Java methods and some mathematical demos which show how the graphs should look. But if I want to test my own method, I can do that too. To test my own method, I'm going to create a test method. I'm going to call it public long, or public static long, because it needs to be static, long my test method. And it's going to take a long as an input. Now the input long represents the size of our data set. So input represents the size of our data set, and then long is the time it takes our method to run. So to do this method, I'll have to fill in a couple things. Let's make this method return log n. So I'm just going to return math.log of input. And of course it wants a long as its output. Now we have to annotate our method as a benchmark to make the tester recognize this as a speed testable method. So I'm going to type at benchmark, and I need to import this as well. So let's import it. And here I give it a name. So I'm going to say name equals my log n test. So now when we run our code with visualizer.launch my class, it's going to look for every method in my class which has this annotation at benchmark, and it's going to add it to my test. So you can see here, now we have my log n test. And this one shows up as well. And if we see somewhere on here, my log n test, it's going to be in blue. And if we just plot that alone, we don't want O of n squared as well, we just want my log n test. It looks like it's kind of flattening out because, of course, we're casting a double to a long. So it's going to be a bit steppy for now because we don't have decimal points. But as we increase it, it should, of course, somewhat smoothen out. And again, the reason it's stepped like that is because we're doing a cast, so it's dropping the decimal point. But if we compare it to something like O of n, and we set the steps per iteration very high, step simulation delay very low, we can see that the graph of log n goes, well, right now, O of n is going quite a lot faster than log n, or quite a lot slower than log n. Now if we just graph log n, we can see that it's, well, it's graphing. Thank you so much. Good luck with your testing, and enjoy. Farewell.